Okay, first we represent the situation using a diagram. So in this triangle ABC, A represents the top position of antenna, D represents the bottom position of antenna, and point C represents a point at the base of the hill. And dB represents the height of the hill, which we have to determine. And from a point at the base of the hill, that is from point C, the angles of elevation to the top and bottom of the antenna is given as for the top it is 28.5 degree, and for the bottom position the angle of elevation is 25 degree. Also the antenna is 90 feet tall. And so let's first consider the right triangle ABC. So in this right triangle ABC, I'm going to apply the trigonometric ratio, that is a tangent trigonometric ratio. So I write a tangent of 28.5 degrees. And this equals the opposite side to 28.5 degree, which is the side AB. And this is divided by the adjacent side, which is BC. And this we write according to Sokotova. And so we can rewrite this as AB basically represents the distance AD plus DB, and we write BC as it is. And so AD equals 90 feet, which is the antenna's height. So we put 90 plus DB represent the height of the hill. So we have represented this by H, and this is divided by PC. And on the left side, we have a tangent of 28.5 degree. Now we will solve for BC from this equation. So first we cross multiply BC, or we multiply both sides by BC, and then we will get BC times this tangent ratio equals 90 plus H, and then we divide both sides by tangent of 28.5 degree and solve for BC. And doing that we get BC equals 90 plus H. This is over tangent of 28.5 degree. And let's say this is equation number 1. Now we are going to consider the another triangle, that is right triangle DBC. So let's consider the right triangle DBC. And in this right triangle, we are going to determine the tangent ratio, that is a tangent of 25 degree, right? Tangent of 25 degree. This equals opposite side to 25 degree, which is DB over BC. So we first write DB over adjacent side is BC, and we know that DB we have represented as height of the hill, which is H. So I write this as H over BC. And this side we have a tangent of 25 degree. Once again we solve for BC from this equation, first by multiplying by BC and then dividing by tangent 25. So therefore we will have BC, and this equals this height H divided by the tangent 25 degree. Let's say this is equation number 2. Now comparing equation 1 and equation 2, we see that the left sides are the same, that is the quantity BC. And that means the right side expression will also be same. So first let me write the right side expression for equation 1, which is 90 plus H, and this is divided by tangent of 28.5 degree, and this must equal the right side expression of equation 2, which is H over tangent of 25 degree. Now we will do the cross multiplication so that we can solve for H from this equation. We had to do the cross multiply like this. And so we can write 90 plus H, this multiplied with the tangent of 25 degree, and this equals H times tangent of 28.5 degree. Let's distribute this tangent 25 degree into the terms inside the bracket. And doing so, we get 90 times of tangent of 25 degree plus h times of tangent of 25 degree, and this equals h times tangent 28.5 degree. We will subtract this expression from both sides, and so on the left side we will have only 90 times of tangent 25 degree, and this equals on the right side we will have 90, h times of tangent of 28.5 degree minus h times of tangent of 25 degree. We see that we can factor the h from the right side expression. We have h here as well as h here, and so this equals when we factor h, this will become h times tangent of 28.5 degree minus tangent of 25 degree, and on the left side we have 90 times tangent 25 degree. And to solve for h, we just have to divide both sides by this expression, so that we will solve for h, and doing so we get 90 times of tangent of 25 degree. This is over tangent of 28.5 degree minus tangent of 25 degree, and this equals h. So we solve for h from this equation. Now we plug this expression into the calculator and approximate the value of h to a whole number. And when we do, we get 548 feet. This is approximated to a whole number. So thus we have determined that the height of the hill equals 548 feet. And this means answer choice C is correct.